We can add, subtract, multiply, divide numbers. We also need to know how to add or subtract vectors. If you have two vectors and you need to add them up, the first step you have to make is you have to redraw the picture. You have to move at least one vector in such a way so its beginning will coincide with the ending of another vector. If I could I use my scissors, I could cut it out of the screen and just shift it. I cannot do that, unfortunately. So I have to use my imagination. Remember, I told you, use imagination. So I would want to do is this. This arrow has to be shifted. So it has to start from this point. Sometimes the beginning of a vector we call a tail, the pointer we call a head. So we should put a tail of A on the head of B. So the rule has a name, the tail to a head rule. Well, unfortunately, if I start redrawing that arrow, I don't have space. The screen cutting it up. So what can I do? Well, I can choose a new point. And first I can redraw the vector B. It must have exactly the same magnitude and exactly the same direction as the original arrow. In that case, that's the same vector. So that's B. Now, from this point, from the head of B, from the end of B, I can redraw the arrow A, tail to head. And again, I must preserve the direction of that arrow and the magnitude. In that case, it's the same vector, just starting at a different place. That's the first step of the procedure. The second, yes?
Does it matter if I go from B to A or A to B?
Good question. Too soon. So we didn't finish this yet. So that's just the first step of the procedure. We don't see yet the resultant, the sum. The resultant is an arrow which connects the very first point with the very last point. This red arrow, well, a standard common notation is an R, the resultant, or S, the sum. That's what we call A plus B. And when we use our handwriting to distinguish, to differ a vector from a number, we usually use, well, like a tiny arrow above a letter. In your textbook and in most textbooks, they don't do it anymore. They usually use a bold font or bold and curved font like this. So you just have to pay attention. For example, this could mean just a number, a magnitude, but this could mean a vector. Well, that's the rule. Now, to answer your question, we can, what can we do? We can start from A, and then we can attach B to it, and then we can draw the resultant, and then we can see if they same or different. So we can start from an A. That's this. Of course, I have to do my best to keep the same direction and the same magnitude. In real life, I would have to use a protractor and a ruler. Now, that's an A. Next arrow, B. And now I have to draw the resultant. I must draw the third arrow. Otherwise, we can't see the sum. And if you look at them, same. So, of course, A plus B equals B plus A for vectors as for numbers. If we have a question, find the magnitude of the resultant. Well, we have two possible approaches. Number one, we actually can draw all vectors as accurate as possible. And then we can just take a ruler and we can measure the length of the resultant. And of course, another approach is using math. Well, right triangles or not right triangles depends on the case. In general, as you can see, the triangle we have is not a right triangle. So we could, well, break it in two right triangles and then work it out. Please take a minute, copy this picture, and draw the resultant. That's the most important exercise for this subtopic, the vector addition. So you just have to take your notebook, draw two arrows in any order, and then repeat the procedure and draw the resultant. Today and tomorrow in the lab, you're going to be using this rule many, many times.
What section do we have for the clicker question?
I'm not sure of your question.
This session ID, the clicker question for the phones. Can I just give the session ID that you're looking at?
I don't use the software. Yesterday I had a similar question. I don't like it. It's kind of buggy, and that's why you cannot use a phone. You should use the actual physical clicker. I've tried it. I didn't like it. And unfortunately, in this situation, it's kind of like Russia. If Putin says, everybody does that. I'm not Putin, but it's kind of like dictatorship. If I really want everybody using a physical clicker, you have to. Sorry. So let's do it together. I can provide a temporary clicker before you get the permanent one. So again, the first arrow, A, looks good to me. I keep it, but I want to redraw the second arrow, B, in such a way so it would start from the head of A. Maybe it's too long, yeah? Okay. So remember, we have to preserve the magnitude and the direction of each arrow if we move it, if we shift it. And now we have to draw the resultant. We always can imagine when we add in vectors, no matter what is the nature of it, velocity, acceleration, there are different physical quantities, but we always can imagine that we actually physically walking that path. So if a person or a ladybug or an ant walks this way, it ends up here. So start, finish. All you have to do is just connect start to the finish. That's going to be the resultant. If I tell you that this is, well, 5 centimeters and this is 8 centimeters. If you treat A plus B as 5 plus 8, you definitely get the wrong result because this like 1, 2, 3, 4, 5.5 centimeters. So adding vectors and adding magnitudes, two different things. Keep it in mind, please. That's wrong.